Okay, so I'm going to be working on this linear algebra problem relating to heat distribution. So I'm going to start off here by reading this paragraph. An important concern in the study of heat transfer is to determine the steady-state temperature distribution of a thin plate when the temperature around the boundary is known. Assume the plate shown in the figure represents a cross-section of a metal beam with negligible heat flow in the direction perpendicular to the plate. Let T1 through T4 denote the temperature at the four interior nodes of the mesh in the figure. The temperature at a node is approximately equal to the average of the four nearest nodes, to the left, above, to the right, and below. For instance, T1 equals 10 plus 20 plus T2 plus T4 divided by 4, or 4T1 minus T2 minus T4 equals 30. Okay, so this is a pretty big question, and I think the first step is to kind of break things down and trim away any excess material that we don't really need to solve the problem. Now, it's being presented to us under this heat distribution lens, and I don't really think that's applicable if we're trying to just set up a system of linear equations. So we can kind of disregard most of this part, as it's just not really useful information. So I think what we should start off here, or how we should start off here, is by looking at this part right here. So this is a sum of four values divided by 4, which is how we would find the average. And those four values are plucked from the nodes surrounding T1. So it's the 20, that 10, that T4, and that T2. And then it's re-expressed here in a different way, and this is just an algebraic re-expression of this equation, so that the right side is just the sum of the two constants. So why don't we kind of start here? They gave us the first equation, and we're going to write them in this format for our system of linear equations. So we have 4T1 minus T2 minus T4 equals 30. And notice here that T3 isn't part of this, so that's our missing variable. Now, I could write these in such a way that you can kind of visualize the gap that what T3 would otherwise occupy, but for the sake of brevity, I think I'm just going to write these out as they would normally be written. So the next one, we're going to move over to this second node, and the four surrounding nodes are T1, 20, 40, and 3. So if we follow this kind of organizational system, we're going to say that negative T1 plus 4 T2 minus T3 equals 60. And again, T4 is the missing variable, and there's going to be one variable absent in each one of these four linear expressions because just the way that they're asking us to retrieve the values from this little diagram. I'm going to just erase this so that we can actively write on it. The next one's going to be the third node. So it's going to be starting with negative T2 plus 4 T3 minus T4 equals 70. Okay, and 70 being the sum of the 40 and 30 right here. Finally, we're going to do T4, and we have T1 again to start. T2 is our missing variable, so we're going to just go over here now to minus T3 plus 4 T4 equals 40. Okay, so now let's put this in augmented matrix form as if we were going to actually be solving the problem. But if you notice here, 33 is actually just asking us to write out the equations. And that's what we've done here. But I think putting in augmented matrix form might help for solving the following problem, 34, and also just to kind of visualize some of the linear algebra mechanics. So we'll start out with 4, negative 1, 0, negative 1, 30, negative 1, 4, negative 1, 0, 60, negative 1, 0, negative 1, 4, negative 1, 70, and finally negative 1, 0, negative 1, 4, 40. So that's going to be our augmented matrix, where this column here is the constants, the B column, and the rest follows. And you can kind of just observe there's already somewhat of a pattern to the way this is arranged. It's very symmetrical, and that should kind of indicate to you that through manipulation you should be able to prove some type of consistency and solve this for actual values for each one of these variables. So I hope that helped, and let me know if there's any other questions you guys have, and have a good day.